Hello, everyone. My name is Yaying, and today we'll be talking about the quarantine extension for Pset8. So if we look at our infected class, we see that when the infected person is done being infected, they can either, be part of the deceased class, meaning that they died from the infection, or they can be part of the recovered class, meaning that the infected person has survived and they have now gained immunity to the disease. But as we can see over here, as the infected person is still being infected, meaning their infection period is not over yet, they have the option of quarantining. So this is over here. Number one, we basically want to have days greater than or equal to C false negative. And this constant is basically the number of days that quarantining can begin after. So this is basically meant to simulate the idea that, it takes X number of days after getting infected for a person to be aware, either through testing or through their symptoms, that they are actually sick and that they actually have the option of quarantining at that point. In this case, we set our C false negative to be 3. So this person has to wait 3 days before they realize they're sick. Another thing is there's also the idea of whether you want to quarantine or not, knowing that you're sick. Obviously, you should quarantine for safety measures, but if we're in a state where, the rules or regulations are really lax, then maybe this will affect the C quarantine constant. And basically, we want to see if this random number is less than C quarantine. And if it is, then they will actually start quarantining. So as you can tell, if C quarantine is really high, then the chances of a person quarantining will be really high. If C quarantine is around 0, then there's a slight possibility, but less of a possibility that they'll start quarantining. To simulate this quarantine process, we basically put them part of the quarantined class. Let's see. And yeah, we can also talk a little bit about what it means to be quarantined. So in this quarantine class, we basically have it so that, as the amount they can step or the amount they can move while they're quarantined is equal to 0, C step size quarantine is 0, and their infectiousness rate is also equal to 0 because they're supposed to be quarantined. And these are all constants that we can mess around with. Let's see. We can also talk a little bit about changing things up. So this is how our code works or looks like normally. Okay, build. The radius of their infection is 4 right now. Here we have a little bit of deaths. The yellow dots basically stimulate centralized quarantining. They're all stuck in this central box and they can't really infect anyone. Let's see what happens if, for example, this disease was actually a lot more infectious than we thought. So even being close to a person will infect the other person. If we make this to 0.6, we can see that over here, the infection rate starts fluctuating a lot more and it also gets higher. And there also seems to be more deaths because, the disease is more infectious. Another thing that we can change, let's change it back to 0.2 so we have constant. Another thing we can change is, let's see, the possibility that people actually begin quarantining. So if this is 1/1, then the possibility that the quarantine is very, very high. In fact, every single time they know they have the disease, they start quarantining, is what this is basically saying. Let's see. Boom. So that's why this disease basically dies out, which is great. Great to know. Another thing, if we were to change it so that even if someone knew they had the disease, they wouldn't quarantine as often, maybe that would be 1/100. It would look like this. Actually, let's change it out of 1/200 to make the effects more drastic. Yeah, so as you can see, even though people know that they're infectious, if they choose not to quarantine, then this is, as we know from real life, this is basically them spreading the disease more. Okay, that's all I have for today. I hope you enjoyed the little presentation thing. Thanks for listening.